everyone, hi. So I can see that Naja is already been there. Yes. So Naja says hi, Surds says hi. Hi guys. Surds says that I've passed my 11th. You're not even in GCSEs and here you are attending the live class of GCSEs. Yes, Suraj. Alright. Who else is there? Okay. So over here it's written the excitement starts here. What are we excited about? We are excited about studying GCSE levels of mathematics while we are still passing 11 plus examination. So 𝗂𝗂𝗏𝗏 says hi. Okay guys, you have really amazing usernames, but I would say that I need to know your real names as well. And if in case you're anybody who's already been studying from me, then I would say comment your name so that I know, okay, this person is that, or we teach, like I am teaching this person. So are you guys all new? I mean, 𝗂𝗂𝗏𝗏, that's your username, right? Hazel Brown says hi. Alright, hi everyone. So what are we going to cover in today's class? We're going to start with Surds. Hazel Brown says maths tricks. Darling, we're not going to discuss maths tricks in every live class, although I will tell you shortcuts, of course, techniques, but this is GCSE levels, right? So we would be discussing some shortcuts of like doing Surds, and I'll tell you innovative ways or, you know, shortcuts in such a way that not exactly it would be a shortcut, but I can say that another way of doing the question in an easier manner. Because in GCSEs, you don't really have a lot of shortcuts. You won't get marks if you do not show your steps, right? But we can think of a question in doing different ways. See, the beauty of math is that you start with any particular question, and there are 100 ways of doing one question. That's it. So that's what I'm here for. I'm going to tell you the easiest way to try and do the questions. In today's class, we'll be doing the following topics. Surds, completing the square, quadratic equations, quadratic graphs, inequalities, all of that. Alright, so starting with the topic surds. Now I want you guys to tell me that what do you understand by the word surds? Have you ever heard of it? If you've done it in school. Surds. What exactly is it? Now it means I'm doing the square root of some number. That's what most of the people tell me. But in reality, I would say it is the square root of a non-square number, right? Like square root 2, square root 3. These are surds. But if I talk about square root 4, 4 is a square number. It is a perfect square. It is the square of 2. Just excuse me for a while. Yeah. So it is a square of 2, right? So over here, square root 4 gives me a proper answer, which is plus minus 2. So it is not a surd. So basically, square root of any non-square number is a surd. Now in your GCSEs, you should identify what kind of questions can be asked. 3 categories. Either you can be asked to simplify a surd. Second category of questions where you have to expand the brackets in which surds are being multiplied, divided, added, subtracted. Third category of rationalizing. Let's see them one by one. Write 5 surd 27 in the form k surd 3. Now since I'm talking about I have to express square root 27 in the form of square root 3. That means that I have to write 27 as a multiple of 3. Can I write it at any ways? This would be 27. 27 can be written as 9 times 3, isn't it? So now you can separate your surds. That means you can do 5 times square root 9 times square root 3. If I talk about square root 9, that is 3 and surd 3 as it is. So this is 15 surd 3. This would be my answer. Got it? So all you have to do is whatever number is given to you in the question, try to express your surd as a multiple of that number. For example, if I want to do the square root 48. Okay, so I see new people joining me over here. Me says hi. Eva Chen says hi. Hi everybody. Alright. Square root 48. How can I write 48 as a multiple of 3? Let's try to do it mentally. I'm doing the first one for you. I want you guys to give me the answer for the second one. Alright. So square root 48 If I want to write 48 as a multiple of 3, 48 is 16 times 3. Now do it mentally. 3 is a non-square number, so we're going to keep it as it is. And square root of 16 is 4. So I got my answer 4 surd 3. Alright, let me write down the steps for you now. So surd 48, it can be written as 16 times 3. I've done square root 16 times square root 3. Square root 16 is 4 and 4 times 3. So they can also ask you to calculate the value of k. K is 4 in this one. In the previous question, k is the number that is being multiplied by surd 3, right? So 15 in the previous question. Now over here, square root 50. Can you guys answer me? Has anybody done the answer? What would be square root for 50? If I want to write it as a multiple of 2, 50 is 25 times 2. Just divide 50. So it is square root 25 times square root 2, which is 5 surd 2. That would give me the answer. Alright, so over here k equals 5. That's the first category of questions that I discussed from Surds. Now the second category of questions, and mark this question as like very important. If your schools plan on giving you difficult questions or a little advanced level questions on your mock exams, they would give you these kinds of questions. And okay, you have learned about how we expand the brackets, how we do for a plus b whole square, that is a square plus b square plus 2ab, right? That's what we discussed in our last live class as well, if you guys attended that. But over here, what are we going to do? I'm not going to expand the brackets. That would take a long time, right? So instead of expanding brackets, I also told you about dots. Dots is difference of two squares. Now over here, there is this first term, let me say this is a, and there is the second term, let me call this second term 2 minus surd 3 as b. I'm ultimately calculating a square minus b square. And I told you guys the formula, that is a plus b times a minus b. I discussed it, that how important this formula is for your GCSE exams. There would always be one question related to factorization of this, alright. So it would be, you just have to add the two terms in first brackets and then subtract the two terms in the next bracket. Now listen to me very carefully about how are we going to apply the formula of dots in this particular question. So now, I am saying that whenever I'm subtracting two squares, I'm going to add the two terms in the first bracket. So in the first bracket, what are the two terms? First term is 2 plus surd 3, write it as it is, plus the second term is 2 minus surd 3. So that becomes my first bracket. Then for the second bracket, I'm going to subtract the two terms. Ignore those squares, just subtract it. So 2 plus surd 3. Now be careful while subtracting because the minus sign is a little, it can mess up with you sometimes. Now whenever we are subtracting, the signs would change. I'll explain you in detail over here. When I'm doing 2 plus surd 3 minus, this is 2 minus surd 3. I'm subtracting the entire bracket. So since there is a negative sign outside the brackets, the signs inside would change. That's why I have written this. Alright. So now, if I want to solve it, see, what is 2 minus 2? 0, of course. So I can just cancel it out from the second bracket. If 2 minus 2 is 0, 3 minus 3 is 0, 5 minus 5 is 0, x minus x is 0, then surd 3 minus surd 3 would also be 0, right? So from the first bracket, I just get 2 plus 2, which is 4, times. The next bracket is surd 3 plus surd 3. Now a lot of people give me the answer as surd 6, which is incorrect. We cannot add our surds together. Surd 2 plus surd 5, that is not equal to surd 7. Alright, although surd 2 times surd 5 is definitely equal to surd 10. We can multiply the surds together, but we cannot add them up or subtract them. So in what particular case I'm going to add it? Just consider it like algebra. Like if I do x plus y, I can't do that, right? But I can do x plus x. X plus x is 2x, isn't it? So surd 3 plus surd 3, that would be 2 times surd 3. If you guys feel a little confused about understanding this, what you can do is assume x is surd 3 Alright, so what would be surd3 plus surd3? That is equal to x plus x. So that is 2x, isn't it? 2x means it is 2 surd 3. That's why I have explained it to you in detail. If in case you guys have any confusion, just make sure that you are answering me in the comment section below and let me know if you're understanding or not. Alright, I want you guys to be active, okay? When you have to text your friends, you're like tack, 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 very fast with your fingers, isn't it? Now I want you to type in the comment section as well to tell me that how are you, understanding it or not, and also let me know if you find any particular concept of math difficult, so that we can take that particular concept in our upcoming live classes, and you would gain benefit from it. Of course, a lot of people have mocks right now. So what we can do is, like, maybe after 2 weeks or 3 weeks, I can take a math live again, and you can get a better practice for your mocks. If you want, we can revise some important major topics of your math exam, right, for your mocks. Alright, so for this one, as I said that we can multiply it. 4 times 2, 8. 8 surd 3 is my answer. I got my answer in 2 easy steps, right? If you would have expanded the brackets, then it would be a little difficult and you would have to do a lot of steps. Now the third category of questions, that is rationalization. Although it does not say that we have to rationalize, but what do we mean by rationalizing? What do we understand when we say the word rationalize? Now if you guys have heard about OCD, has anybody heard about OCD? It's a disorder, like, for example, if I have a bottle in my hand and the cap is open, right? So it would kind of irritate me, isn't it? I will have that inner urge to just close the cap, right? So over here, similarly, our surds in math have a little bit of OCD. That means that they do not, they do not adjust themselves in the denominator. Alright, surds are okay if they're in the numerator, but they do not like themselves in the denominator. So that's why we have introduced the concept of rationalizing. Rationalizing means that we are going to remove the denominator, remove the surd from the denominator. And while doing that, how do we do it? First, I'm going to explain you the basic concept. Like if I have 2 over surd 3. Just giving you a basic example, we'll do the question later. Alright, so if I want to rationalize it, if I want to remove the denominator, whatever number is there in the denominator, we'll try to multiply and divide it by the same. Why? Tell me one thing. If I multiply it by 1, will it change? Anything multiplied by 1 is the number itself, isn't it? So of course it won't change. So I can multiply by 1. Now 2 divided by 2 is 1. 3 divided by 3 is 1. So surd 3 divided by surd 3, that will also be 1. Right? So over here, since I've written surd 3, so I'll divide by surd 3. Alright? I'll divide by surd 3. Now, don't cancel it out, because usually people first multiply and divide it and then they strike it off. No. And an important concept, that surd x times surd x is always x. Like if you do surd 3 times surd 3, 3 times 3, 9. Square root of 9, 3 again. If you do square root of, let's say, 4 times square root 4. So that means it is square root of 16, which is going to give you 4 again. So this will always give you the number itself. So in the denominator we have 3. And in the numerator we have this. Ultimately I've removed the denominator, I've removed the surd from the denominator. So that's all I had to do. Alright? So that's the concept of rationalizing. Now how do we rationalize if I have something being added or something being subtracted? In that case, you just change the sign. We call it conjugate in higher level of mathematics, although we use these kind of terms in university levels. We don't use them in school levels basically. But I'm telling you a cool word if you want to learn it. It's conjugate. Conjugate means, like if I have 2 plus surd 3, the conjugate of this would be 2 minus surd 3. Just flip the sign in the middle. If it is 5 minus surd 6, so the conjugate would be 5 plus surd 6. Basically taking the opposite signs that is there in the middle. So now I will multiply and divide it by that. So over here, keep everything as it is. Conjugate of the denominator, that is going to be 2 minus 𝗬3. So you multiply and divide by the same. Now since you're multiplying an entire number in the numerator, this is 5 plus 2 𝗬3 and this is 2 minus 𝗬3. Use your FOIL. In case you do not know what FOIL is, go and watch the last live that was there, the math live of GCSEs, and you would get to know that how I've explained over there that how we expand the brackets. So this is 5 plus 2 𝗬3 times 2 minus 𝗬3. 5 times 2, 10. Then 5 times 𝗬3, negative 5 𝗬3. Then multiplying this, which is 4 𝗬3, and then multiplying this, which is minus 2 times 𝗬3 times 𝗬3 is 3. 2 times 3, 6. So negative 6. And in the denominator, now you see, in one term, in one bracket, I have 2 plus 𝗬3. And in another bracket, I have 2 minus 𝗬3. How do we do it? In one bracket, addition, and another bracket, subtraction. Ring the bells, dots. That is difference of two squares, right? So it is 2 square minus 𝗬3 squared. So this is 10 minus 6, which is 4, minus 5 𝗬3 plus 4 𝗬3. Now it is similar to adding minus 5x and 4x. Negative 5 plus 4, that is negative 1. So it is just going to be negative of x, that means negative of 𝗬3, divided by 2 square is 4, 𝗬3 square is 3, so 4 minus 𝗬3 divided by 1, which is just 4 minus 𝗬3. I hope you guys understood the concept of surds. This was just the basic that I told you about surds. Alright, the basic kinds of questions actually, not exactly the basic. The three category of questions. First of all, we are simplifying the surds. Second of all, we are expanding the brackets using different identities, algebraic identities to simplify it. And the third one where we have to rationalize it. Now coming to the next concept of quadratic equations. What do we understand by quadratic equation? Any equation in which the highest power of the variable is 2. That would be called a quadratic equation. So I need the term of x square. Over here, x square could be multiplied by some number like 2x square, 3x square, or 5x square plus 7x plus 3, anything like that. But make sure that this number is not 0, because if a is 0, then it is not a quadratic equation anymore, right? It becomes a linear equation. I'm so sorry. So over here, a, b and c. A is the term that is being multiplied by x square, b is the term that is being multiplied by x, and c is my constant term, right? This is the general form of the quadratic equation. Now using this general form, let's see how we can study completing the square method. Sometimes an equation would be given to you, alright, and they can ask you that you have to complete the square. That means you have to write the equation in the form x plus p whole square plus q. You have to write something like that. So what exactly are we trying to do over here? Suppose I talk about x square. Now use this, the name of the method to understand the method. If I talk about x square, it is completing the square. Draw a square. This is x times x. The area becomes x square, right? Now if I say that I have to solve for, I'm going to explain you for x square plus bx first. Let's try to understand that. So if I want to solve x square plus bx, x square, that means it is x times x, x square, plus, let's say I'm taking a rectangle with the width is the same, x, and this over here is b. Now what I can do is, I can split this another rectangle in two parts, right? So that this length, this small length, becomes half of b. So I can further write it as, let me just redraw it. I'm taking this x square as it is, x and x, and I've taken the half rectangle as it is. So over here the width becomes b/2 and x, and another rectangle, the second one over here, this one, right, I'm taking over here. So now I've just, from vertical, I've placed it horizontally. So this is b/2 and x. Now what is left? What part is left? If you see the whole square, right, I'm still left with this part, the dotted part that I'm drawing, alright? So I'm still left with this part. Now what will be the value? Otherwise, if we have like x square plus dx, let's say I have plus c. What is the constant that I'm adding? So over here, you can see that this is b/2, this is b/2. So if I calculate this particular area, this would be b²/4. So what exactly am I going to do to complete the square method? I'm just going to add and subtract the square of half of coefficient of x. Remember that. I'm repeating again, the square of half of coefficient of x. I'll tell you two ways in doing it. One would be the standard way, of course. You need to understand the concept as well. And second way would be the shortcut, alright, in which you'll be able to do it directly. So let's have a look at the question. For example, if I want to solve this question, write x square plus 10x plus 2 in this form. Like I have to complete the square. If you're seeing a square plus some other constant, remember that this is going to be just completing the square method. So what are we going to start with? X square plus 10x, write it as it is. Now over here, what term is being multiplied by x? That is 10. As I said, square of half of coefficient of x. So square of half. 10/2, I mean half of 10 is 2, sorry. Half of 10 is 5 and 5 square. This becomes 25, right? So over here, I'm going to add 25 and I'm going to subtract 25. Now whatever you're subtracting, take it separately, and whatever you're adding, take it in one brackets. Alright, 25 is 5 square, isn't it? If you see the first bracket, it is nothing but x plus 5 squared. How am I getting that? Because 10x can be written as 2 times 5 times x, and 25 is 5 square. And you know the identity that I told you in the last live class, a plus b whole square equals a square plus b square plus 2ab. So I'm going to write it minus 25 plus 2, that is negative 23. If you find this way as confusing, I'll tell you another way as well. The other way to do is that you can simply remember it by a formula. For example, if I have any equation x square plus bx plus c, and if you want to complete the square using this equation, add the half of coefficient of x, that is b/2, right? Keep the c as it is and subtract the half of coefficient of x. If you simply remember the formula, all you have to do is substitute the values of b and c. That's it. Also take care of the fact that over here I'm specifically taking a as 1. The formula would ultimately be a little different. It would be b/2a if something was being multiplied by x square as well, like some another number like 2, 3, 4. If that was being multiplied by x square, then we would have a little different answer. Alright, I hope you guys are understanding this. In case I'm repeating again, if you have any doubts, you know where you have to ping me, right? Okay, so now if I see b is just 10, so I can do it directly. X plus 5 squared plus 2 minus 25. Again, the same answer that I'm getting, right? Now, if I want to do this, find the coordinates of the turning point. Let me tell you, whenever I'm completing the square method, I can directly say that, like suppose I'm writing it in the form x minus h square plus k, something like that, right? If this is the general form of, let's say, completing the square method, then you can directly say that the turning point, without calculating anything, you can directly say that the turning point will be having coordinates h, k. Alright, so now over here if I want to solve it, first of all what do you need to do? You need to complete the square. So over here, x square plus 8x plus 3, this would be x plus half of 8, that is 4. I'm doing it mentally now, understand it. Half of 8, 4 square, plus 3 minus, again half of 8 is 4, 4 square, that is 16. So I get as x plus 4 whole square minus 13. Now as I told you, if it is x minus h whole square plus k, your TP, that is the turning point, sounds more cool. So TP comes out to be h, k. When the sign is negative inside, then h comes out to be positive. Alright, so over here if I already have a positive sign, I would say that the turning point is -4, whatever sign is there over here, like whatever sign is over here, I'm going to take the opposite of that. So -4, comma, and keep this sign as it is, -13. So these are the coordinates of my turning point. So in completing the square method, there are again 3 types of questions. First of all, they can directly ask you to complete the square, that is, write your given equation in this particular format. That's one category. Second category is where they can ask you to find out the turning point. And the third category is where they can ask you to solve the equation and give your answer in Surd form. Now I want everybody of you to be very, very attentive, because this is the last question for today. Alright, and if in case you have any doubts, as I said, you can ask me. Alright, so now over here, if I want to do completing the square method, again, first of all, b is 10. So you do half of 10. Now Advait is over here saying hi. Advait, don't you think that you're a little late, or were you already there and you texted later? Yes, Advait? Okay, continuing over here and waiting for your comments as well. If I want to complete the square, take the half of it and then square it. So half of 10, that is 5. So I'll write x plus 5 whole square, -3 as it is, minus, what do we subtract? The half of coefficient of x, that is 5, squared. So you're doing -3 minus 25, right? This is equal to 0. That means x plus 5 whole square minus 27 equals 0. That's what we are getting. Sorry, minus 28 equals 0. Now, how do I calculate the value of x over here? I need to make x as the subject. Add 25 on both the sides. This becomes 28 on right side. And if I do x plus 5, take square root on both the sides. So this is square root 28. Now, one grave mistake that you need to avoid is that whenever you're taking square root, alright, make sure that you're writing a plus minus. Okay, so we have to give plus minus. So Advait is giving me the answer in decimal. Advait, let me tell you one thing, read the question very, very carefully. It asks you to give the answer in the Surd form. Alright, okay, so Advait says that he's just joined. Advait, we're just about to end, but no, anyways, this would be a recorded class. You know that, this will be uploaded on the website later. So you can rewatch the part that you have missed. We have just covered Surds and we have done quadratic equations, and I've explained you completing the square method as well. Alright, and in our next live class, we can continue with topic like quadratic graphs and inequalities. I'll show that to you today as well, that what we are going to cover for the next live. So over here, if I'm doing x plus 5 equals plus minus Surd 28, subtract 5 on both the sides. This is x equals -5 plus minus Surd 28. And this would be my answer. Now, you can also simplify Surd 28 if you want to, right? Surd 28, we just discussed how we can simplify it. 28 is 4 times 7, right? So I can write it as -5. Surd 4 is 2. and Surds 7 as it is. So I'm not getting one answer, I'm getting two answers over here. -5 plus minus 2 Surds 7. So this would be considered as the correct answer. I hope you guys understood. If in case you have any doubts, you can just ask me in the comment section below. And this is what we discussed. We discussed about Surds, quadratic equations, and completing the square method. If you want that, if you have any doubts, as I said, that you can let me know in the comment section below, or you can let me know in the classes as well, and we can take up like mock revisions. We can take up the difficult topics. This completing the square method was a topic that was requested in the last live class, so that's why I took it. For the next live class, we can take quadratic graphs, and I can explain you what exactly are quadratic graphs, how we can translate them, how we can transform them, like where do we, where do they touch the x-axis, the x-intercept, the y-intercept, and then how can we solve the quadratic inequalities. We can discuss these kinds of questions, right? But not today. We will be doing them in the next class. Many thanks for joining us today. I'll be seeing you guys in the next live class someday on Saturday. All right. Hope to see you soon again, very, very soon. Take care, everybody. Bye-bye.